Hello everyone, hope you are all doing well. This is Vidyashri. In this video, I am going to teach you a trick on temperature coefficient. So without moving directly into the trick, let us just recall what is the temperature coefficient for a chemical reaction. So we all know that rate constant for a chemical reaction is represented by K. So let me write that rate constant is K. Now, if the same reaction is performed at a temperature 10 degrees more than that of the temperature. So, rate constant is K at temperature T. Now, at temperature T plus 10, let me write the rate constant as K T plus 10. So the temperature coefficient is the ratio of these two rate constant. So if I denote temperature coefficient as mu, it is the ratios of rate constant of a chemical reaction to the rate constant at a 10 degrees centigrade more temperature. So it is K T plus 10 divided by K. So this ratio Kt plus 10 divided by K gives us temperature coefficient of a chemical reaction. Now coming to the trick. So this particular trick can be used when in the question you are provided with temperature coefficient of a chemical reaction, and they are asking you how many times the rate of reaction has been increased. Okay, I hope you are able to understand what I am telling. In the question you are provided with the temperature coefficient for a chemical reaction, and you will be asked over a given range of temperature how many times the rate of reaction has been increased. Right? So now let us look into a question and I'll tell you how to solve it very quickly with the help of trick. Consider the question. The rate of a reaction becomes twice for every 10 degrees centigrade rise in temperature. How many times rate of reaction will be increased when the temperature is changed from 25 degrees centigrade to 55 degrees centigrade? Go through the question again. Rate of reaction becomes twice for every 10 degree rise in temperature. So when we increase temperature by 10 degrees centigrade, rate of reaction becomes twice. Right? So means they told that 10 degree rise in temperature is observed. Okay? Then that particular value, if we take the ratio of rate constant by 10 degree centigrade to the original, whatever the value we get, that is the temperature coefficient, right? So they told rate becomes twice, means when we take the ratio of the rates at a given temperature and 10 degree more than that, we are going to get 2. So means we are provided with the value of temperature coefficient. So you should make it clear, you should go through the question correctly, right? So temperature coefficient is given, that is 2. So this temperature coefficient, I'll denote it as mu. How many times rate of reaction will be increased when temperature is changing from 25 degrees centigrade to 55 degrees centigrade? Temperature is changing from 25 degrees centigrade to 55 degrees centigrade. For every 10 degrees centigrade, rate is increased 2 times. So here I'll make this intervals at a difference of 10 degrees centigrade. So this is first method how you can solve this particular question. So 25 plus 10, that is 35 degrees centigrade, plus 10 45 degrees centigrade, and plus 10 we have 55 degrees centigrade. So why I have written it in the interval of 10 degrees centigrade is because temperature coefficient is defined for 10 degree rise in temperature. So when the temperature is increased from 25 to 35 degrees centigrade, if the initial rate of reaction is R, then after 10 degree rise in temperature, rate of reaction will become 2R. Again, 35 to 45 degrees centigrade, 10 degree increase in temperature is observed. So now the rate will become 2 times 2R. So the rate is 4R. Again, from 45 to 55 degrees centigrade, we observe 10 degree rise in temperature. Again, the rate is doubled. So it's 4 into 2, it is 8R. So therefore, answer here is that rate of reaction will become 8 times that of the initial reaction when the temperature is changed from 25 degree centigrade to 55 degree centigrade. Now coming to the second method. So here I'll give you a formula using which you can easily find the change in the rate. Okay. So here rate change is equal to mu delta T divided by 10. Mu to the power delta T divided by 10. So this delta T is nothing but T2 minus T1 divided by 10. So this is a short formula using which you can solve this type of problems. So rate change is given by mu to the power delta T divided by 10. Delta T is nothing but the difference in the temperature T2 minus T1. Quickly applying this. So here the value of mu that's given, it is the temperature coefficient. So it is 2. T2 is the temperature to which the reaction has been reached at the end. It is 55 degrees centigrade. T1 is 25 degree centigrade. Substituting these values into the formula that I have written, so I can write rate change is equal to mu to the power delta T by 10. So mu is 2 rise to delta T. It is 55 minus 25 divided by 10. So it is 2 rise to the power. Difference between 55 and 25. It is 30 divided by 10. 30 by 10 is 3. So we have 2 to the power 3. It is 2 cube, which is 2 into 2 into 2. So 2 cube is 8. So the rate change is 8 times, and therefore right answer is option A, that is 8. Now let us see second question. Similarly, you can solve this also. Let's do it together. Temperature coefficient of a reaction is 2. When the temperature is increased from 30 degrees centigrade to 80 degrees centigrade, rate of the reaction increases by option A 32 times, option B 16 times, option C 128 times, and option D 64 times. Here they have given us temperature coefficient of the reaction mu is equal to 2, and the temperature is increased from 30 degrees centigrade to 80 degree centigrade. So we are asked to calculate increase in rate of the reaction. So by method 1, let us solve it. So just that will be a practice. So we will write the temperatures in the intervals of 10 degrees centigrade, 30 degrees centigrade, 40 degrees centigrade, then it is 50 degrees centigrade, 60 degrees centigrade, 70 degrees centigrade, and 80 degree centigrade. So initially let us consider rate as R. Then when temperature is increased by 40 degrees centigrade, rate of reaction will be 2R. It's because for every 10 degree rise in temperature, rate of the reaction increases twice. From 40 to 50 degrees centigrade, again the rate will double. So therefore it is 4R. 50 to 60, rate will double. So it's 2 into 4, 8R. 60 to 70 degrees centigrade, rate will double again. So it's 2 into 8, 16 hour, 70 to 80, again 10 degree rise in the temperature. So it is 32 hour. So therefore, answer is the rate of reaction increases by 32 times. So the other method, which I feel it is very quick, you can solve using this. So rate change is equal to the formula temperature coefficient rise to delta T divided by 10. So which is equal to temperature coefficient T2 minus T1 divided by 10. So here mu to the power delta T is 80 degree minus 30 degree divided by 10. So the value of mu I will substitute, it is temperature coefficient. So it is 2 to the power of 50 divided by 10, which is equal to 2 to the power of 5. That is nothing but 2 into 2 into 2 into 2, 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So rate of the reaction increases by 32 times, and therefore right answer here is option A, 32 times. I have substituted in the elaborated manner here. So you know that the difference between 30 degree and 80 degree centigrade is 50 degree centigrade. So directly you can substitute 2 to the power of 50 divided by 10. It's 2 to the power of 5, which is 32 times. So let's see another question and let's solve it. Question is, the rate of a reaction becomes thrice for every 10 degree rise in temperature. How many times rate of reaction will be increased when the temperature is changed from 25 degrees centigrade to 55 degrees centigrade? Option A is 3, option B 9, option C 27, option D 81. So just try to quickly solve this particular question. Okay. So you just pause the video, try to solve it, then come back to the video and check the answer. Now they have given rate of reaction becomes thrice for every 10 degree rise in temperature, means the temperature coefficient mu is 3. And the temperature is changing from 25 degrees centigrade to 55 degree centigrade. So we are asked to find rate change. So I'll be directly using this second method. Okay. So rate change, you can use either first method or second method, which is equal to mu delta T divided by 10. Mu is 3 now, which is rise to delta T. It is 55 minus 25 divided by 10. 55 minus 25 is 30 divided by 10. So 30 by 10 is 3. So it is 3 cube or 3 to the power 3. So it's 3 into 3 into 3. 3 multiplied 3 times. So 3 into 3 is 9. 9 into 3 is 27. So and therefore rate of reaction is increased by 27 times when temperature is increased from 25 degrees centigrade to 55 degrees centigrade. So here right answer is option C, 27. Here you have another question. Rate of reaction becomes twice for every 10 degree rise in temperature. How many times rate of reaction will be increased when temperature is changed from 30 degrees centigrade to 100 degrees centigrade? Option A, 500, option B, 250, option C, 128, and option D, 64. So rate of reaction becomes twice for every 10 degree rise in temperature. So therefore, temperature coefficient mu is 2. And here, temperature is changing from 30 degrees centigrade to 100 degrees centigrade. Means T2 is 100, T1 is 30 degrees centigrade, delta T is T2 minus T1, that's equal to 100 minus 30 degrees centigrade, which is equal to 70 degrees centigrade. So rate change is equal to mu rise to delta T divided by 10, which is equal to 2 rise to 70 by 10, which is equal to 2 rise to 7. That is equal to 2 into 2 into 2 into 2 into 2 into 2. So totally 2 multiplied 7 times. This is equal to 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 into 2 is 64, 64 into 2 is 128. So rate of the reaction increases 128 times when the temperature is increased from 30 degrees centigrade to 100 degrees centigrade. I hope you have understood this trick on the temperature coefficient of a chemical reaction. So in order to find the rate change for a chemical reaction when temperature coefficient is given, so rate change is equal to temperature coefficient rise to delta T divided by 10. So you can use this particular formula and you can quickly solve the problems on temperature coefficient of a chemical reaction. I'll meet you with another trick in my next video. Until then, stay connected, keep learning. Take care, bye-bye.